Hey, physical geographers. So following fluvial processes, we're going to go into Chapter 17, Karst and Hydrothermal processes. Pretty good fit. So let's do our quick outline. Impact of solution processes on landscape, dissolution, and precipitation, caverns and related features, karst topography. So we'll talk about a few samples in here you can use with your, essentially your discussion and your lab, so forth. Okay. Hydrothermal features from hot springs to geysers to fumaroles to hydrothermal features in Yellowstone. Yellowstone's very large caldera top of a volcano. You see a lot of geothermal activity in Yellowstone. Great example. So we're going to talk about dissolution and precipitation. There's really a couple of things this is based on. One is almost all groundwater has chemical impurities. Groundwater is typically a weak solution to carbonic acid or dissolved CO2, carbon dioxide gas. Carbonation is a chemical weathering process that dissolves bedrock. So most water can dissolve bedrock. It doesn't matter how much time. Once present relative to solubility of water, it's common rock forming element. So when we say solubility, the ability of water to dissolve is what solubility is. Smaller lumps dissolve quicker. That makes sense because it takes less work. Dissolution, removal of bedrock through chemical weathering. So we kind of piece together how that all happens through the carbonic acid. So here's some samples: calcium carbonate and sulfuric acid, if you will. Roll up bedrock structure, plenty of joints and bedding plants, a lot of groundwater penetration into rock. Also formation of lithosphere, moving water drains away dissolved materials replaced by fresh water to repeat the process. So here we see a cross-section or a profile, essentially of where water, some fluids are in the bedrock. We see stalagmites and stalactites, notice from the top and from the bottom. And we see a column, basically an underground reservoir, if you will, in the bedrock. We can also have chemical precipitation from solution back into solid form. Mineral-rich water in a cave trickles. So really great example of this in New Mexico, Carlsbad Caverns. A great example. You can go well down into the canyon and see a lot of this activity. You have some time to travel there, or perhaps you've been there already. Okay, precipitation processes, hot springs and geysers. Great example of this is Yellowstone National Park. Great place to go and visit and see the outdoors. Provide accumulation of precipitated materials. Hot water is a better solvent, has more dissolved minerals, so hot water has a higher capacity to dissolve, or it's more soluble when it's hot. There's a couple other ways of looking at that. Exception in solubility of carbon dioxide is better dissolved by cold water. Okay, so CO2, we talked about being in it, better dissolved by cold water. So caverns, we saw some examples. This is kind of a blown up, more detailed version. Stalactites and stalagmites from the bottom, stalactites from the top of the column. Blow up of that reservoir we had earlier. More detail. Speleothemes, features formed by precipitated deposits of minerals on a wall. So see examples of that. Both the stalactites and stalagmites. Then karst topography, a great example of this is Japan. You see a lot of karst topography in Japan. Soluble bedrock, essentially forming caves, typically irregular shaped. Karst, we could have sinkholes, collapsed sinkholes, chain intersecting sinkholes, all kinds of different landforms. Anything you can imagine being dissolved by rock, or rock being dissolved. Tower course, conical or hemispherical shapes with vertical slides. There's examples of that here. Groundwater extraction, sinkhole formation. See some of that in Florida. Geysers, once again, when we're jumping back to Yellowstone, we see quite a bit of that. Geothermal pressure, heating up water and expanding, coming to the surface, sometimes forming hot spray, which is a geyser eruption. We see on the bottom right there. Fumarole, surface crack directly connected to a deep-seated heat source. So what's different from that? From a geyser, this is more of a crack than an opening or a hole. Hydrothermal features in Yellowstone, volcanic eruption 640,000 years ago. Very large caldera. the geothermal process does feed and heat up Yellowstone Lake. You learned when we were there a few years ago. Of the world's 425 geysers, Yellowstone contains about 225, so it has about half of the geothermal activity in the world in the form of geysers. Really interesting. Great map right here if you get a chance to visit there. Wyoming, Puerto Montana. Great place to go. It also subtly goes into Idaho. Okay, so we finished up Chapter 17.